Okay, so welcome everyone to part 2 of an introduction into Flutter. I have a lot of content to go through. Not sure if we'll be able to get through all of it. One thing I will say is that once we approach towards 8 o'clock and I haven't gotten through everything, I'll probably give a second for Mike to say anything that he wants to before everyone goes, and I'll be hanging around if anyone wants to go through the extra content, because in running through this, it was at least an hour and a half, and I don't want to keep everyone later than they want to be. So
I won't have anything to say either. So.
Oh, okay. Well, then feel free to leave whenever you want.
No, I'm gonna hang out. I won't have anything to chime in at the end. Yep.
Cool.
I'll preemptively thank everyone for being here. There we go.
Right on. So last month was kind of part 1 of this presentation, where we took a step back and talked about the programming language that powers Flutter itself, Dart. That was about half of the presentation, just going over some of the basic syntax and features that Dart offers. And then towards the end, towards the end of last month, or the last meeting, we created a brand new Flutter project and kind of went through the absolute basics of Flutter, like the basic concepts. And in there, we talked about widgets. And in Flutter, every part of your app, every piece of it that you can touch and feel is a widget. Every part of the UI, every interaction, every bit of layout is handled with a widget. And you build your app by composing all these widgets that the Flutter framework has provided for you. And you compose them inside of your own widgets. And when you go to create your own widgets, we covered there's a couple different types of widgets that you can create. There are stateless widgets, which kind of, as the name describes, they're a widget that contains no state, no internal state, nothing mutable about it. In fact, the classes themselves are marked as immutable. None of their properties are allowed to change. Every property must be marked as final, so it can't even change after its constructor has been run. Then we also talked about the stateful widget, which when to create a stateful widget, you end up creating these 2 classes, one to represent the widget itself, which is still an immutable class, and then the other, a state object that actually contains the build method as well as some mutable state. And then inside of that build method, depending on maybe like a user interaction or some kind of asynchronous event, you can call setState and update some properties in your state object, and Flutter will automatically re-render your view to show that new state. So those are the 2 basic widgets that we dove into. Today we're gonna start by kind of going over some of the basic UI widgets that Flutter provides. So we're going to talk about buttons, we're going to talk about text, we're going to talk about containers, and then we're also going to take a second and talk about widgets that are used for layout and arranging widgets on the screen, or arranging other widgets on the screen. Then we're also going to talk about forms and inputs. This is something I might skip over if we're not doing too great on time, and I might swing back around to that, because it isn't totally essential to get through all this. Then the next part, we're going to look at least one state management solution. Flutter is pretty agnostic to how you manage your state. You can use just about any technology you want. I'm going to show one that the Flutter community has put together that ends up keeping some kind of app level state stored globally incredibly easy. Next, we're going to take a look at networking in Flutter. How do we make API calls and pull in some data, and also how to work with JSON type data in Flutter. And then the last thing we're going to do is we're going to talk about how to interact directly with the native SDKs. We're going to show how you can write a little bit of Flutter code that will then launch some code in Android and Kotlin or in iOS using Swift. That's also something that might get cut for time. Once again, I'll hang around if things go longer and go through them anyways, but you're welcome to leave after whenever you need to. Okay, so let me make sure I have everything open that I need. Okay, so in a Flutter app, the entry point into your app is this main.dart file. And I'm not going to open this up at first. I'm actually going to skip into one of these screens I've created. This having this folder here named screens that has nothing to do with Flutter. It's just a convention, a way to organize all the various screens in this app. And in here, I have a basic UI widgets screen. And how I have this set up is this screen is itself a stateless widget. And when the app boots up and I navigate to the appropriate screen, then this build method will get called and all of this content is going to get displayed into the screen. Now, the first element in here, the first widget in here is a scaffold. And while I'm talking about this, let me actually go ahead and start up this app in the iOS simulator that I have running right over here. So let me go to run main. Okay. And while that's happening, so Scaffold is a widget for essentially kind of laying out the bare bones of an app. It kind of has some built-in notions about what UI elements live in an app. So you can see right here, one of the first properties I'm passing in is an app bar. And lots of apps have an app bar. That's the bar you see at the very top of the app that contains some title and maybe a back button or some other action items. And so Flutter uses the scaffold widget to lay out all those various types of widgets. If I actually go look at the documentation for scaffold, we can also see I can pass in a floating action button, and Flutter will automatically lay out that floating action button in the appropriate place. I can pass in a drawer, which is going to add like a navigation drawer that I can swipe in from the left or the right. I can add in a bottom navigation bar and have maybe some tabs down here at the bottom. And so the scaffold, once again, it's just there for some kind of basic app structure, if you will. So to get to this screen that I'm working on, I'm going to go to this built-in widgets button and then this basic UI widgets. And here is the screen that we're currently editing. You can see that that's the screen because if I update some text here, Flutter automatically reloads the app over there to represent what my code to represent my latest code change. Now, one of the properties in Scaffold is a body. And the body is this big white area on the screen right here. And you can pass it any type of widget. So I could replace this container with, let's say, a text widget, which is just a widget that renders out some text. I can render a, let's see, what's another good one? I could render a raised button that takes a child, and that child is therefore some text. And it looks disabled right now because we missed an additional property here called onPressed, which is a callback that gets fired whenever the button gets pressed. And now you can see that actually is beginning to look a little bit more like a button. Now, one thing I'm going to do to kind of finish off this demo on this screen is I'm going to skip ahead just a little bit and add a widget called column. And don't worry too much about what column is doing. If you kind of look at the name, it might make some sense at first what exactly, what did I put here? 1 second, let me look at my reference. Screen. Stars, yeah. But just know that a column takes in an array of widgets instead of just a single widget. And what it does is it stacks those widgets on top of one another. So if I add several text widgets in here, you can see, I mean, it's a little bit small, but you can see that all three of those show up one right after the other. Now, another widget that you end up using a lot is the padding widget. And a padding widget does kind of what's in the name. It takes in a child widget, let's say another piece of text. And then it also takes in a padding property. And you might at first think that this padding property is maybe just an integer to represent the amount of padding to be added, but it actually wants an instance of an edge insets class. So if I type out edge insets, there's a couple of different constructors I can use on edge insets. One of them is all, which adds the padding to all sides. So this is going to add 20 pixels of padding around this piece of text, so on all four sides. There's also the symmetric option, where I can specify the horizontal spacing or the vertical spacing. And so in this case, you can see the height adjusted at least a little bit. Let me make this like way more. Now you can see that the height went way up. If I make this, then the horizontal is different. And then there's also an only version of edge and sets to specify the left and or top, right, bottom, all of those independently of one another. So for this, let's just go back to all. Next, we have the container widget. And container is a really versatile widget. It does quite a few things because it's actually several widgets put together. For instance, container actually has a padding property because it technically has a padding built into it. But the kind of easiest way to explain containers, it's kind of the equivalent of a div in CSS. It's just something you use to kind of contain some other widget and maybe do something with it. So one thing I can do, I can also not contain another widget and instead just provide some width and height constraints. So I could say width 200, height 100, and then give this some kind of color, which will set its background color. We'll say colors.green. And you can see now we have a box on the screen that's 100 by 200 by 100. I can also add a container that wraps a child. And whenever I provide a child, I don't actually, the width and height on a container is entirely optional. And when we get to our section about layout, we'll kind of talk about the different ways container will behave depending on the properties you pass in. But what I'll explain right now is if you pass a child to container, is that the container itself tries to be as small as the child. So if I, let's come up here and change text here to be pink or something like that, and we'll say I am in a container. You'll see here that the container itself is just as large as the text. It's no bigger, it's no smaller. But I could also, come in and add some padding. Edge and set stop all 10. And now we have a little bit of spacing in between the container and the padding. And so the container has been forced to grow a little bit in size. I showed a second ago the raised button. I don't need to retype that one out. Basically, actually I will real quick so we can show the on pressed. So I can just print out button pressed. If I pop open my console here and click the button, you'll see that it prints out on pressed. And there's a whole bunch of customization options for raised buttons. There's also a flat button that doesn't have these shadows on it. You can also adjust things like the text color, the background color, the color in various states, because one thing I showed kind of on accident earlier is that if I don't even provide an on pressed, the button changes to something else. It changes to this dark gray, and that's because if you're not listening to the event, then Flutter assumes that the button is disabled. So if you ever set the on pressed to be basically null, if on pressed is ever null, then it'll render that way. Back to this. We also have a card widget. And card kind of behaves a lot like container, not in every way, but it essentially adds kind of the material design card theme or card style to some widget. So if I provide another text widget here, this is probably going to be a little hard to see, and I'll actually increase the elevation so the shadow is even more pronounced. But you can see here that now I have this little white section surrounding the text with a shadow around it. Now, card actually isn't exactly like container because it doesn't have a padding property, but I remember there's a padding widget that I can always add. And padding will then add some space in between those. And then the last widget that I want to talk about, and this is really just like barely scratching the surface when it comes to Flutter's widgets. There's widgets for just about anything. I mean, just looking at Scaffold kind of showed some of the basic things like a bottom navigation bar with tabs or a floating action button. These are things that you can use throughout the Flutter framework. But another one I want to show off is a gesture detector, which, as its name suggests, it detects gestures. So I can provide gesture detector a child, and I'll just provide it a copy of our detector. of our card here. Maybe I'll make it a little bit bigger. And then another property I'll do is I'll type out on here, and we can see my IDE is auto-completing all the various gestures that we can listen to. So we can listen for drags on this element, long presses, taps, hands, you name it, like any type of event you would want to listen to. I'll just do on tap, just like the button here. And we'll just print out card tapped. And now we can see here, if I tap anywhere on that card, I get that card tapped. Same thing with the button. So, you know, if you want to make any part of your UI clickable, this is a built-in widget that handles it perfectly. Okay, so next, let's go talk about layout widgets. So let me check out the correct branch here. Changes, go to layout widgets, start. Okay, so I'm going to go here into layout widgets, and I'm going to close this file and go to the layout widgets screen. And this looks exactly like it did before. The reason I've separated all these screens out like this is I have a GitHub repo that I'll make public at the end of this and share the link in Slack so you can come back and reference any of the things that I'm showing off here. So the first thing I'm going to do is we're going to talk about the center widget. So center, by default, it tries to take a child and center it however possible. So if I just simply provide it like a bit of text here, we can see here that that shows up directly in the center of the screen. And before I go too much further, I kind of want to talk a little bit about why exactly this works, because it's kind of interesting. So before I talk about that, let's first talk a little bit about how Flutter's widgets size themselves, how a widget determines its own size. So everything starts with the parent widget passing the child widget some set of constraints. It says, hey, child, here's how much space you have to work with, right? You have this much width and this much height to work with. And then the child widget will use that and maybe make some adjustments to how it was determining how to lay itself out. It maybe make, and then it'll take those constraints and pass them down to its children. Now, it may actually modify those constraints, right? Let's say, I don't know, the padding widget kind of modifies how much total available space there is by adding some extra border around. And so these constraints get passed all the way down to the very bottom children. But then when Flutter's actually doing layout, the parent ultimately determines how a child will be laid out. A child can say, I want to be this size, but the parent may override them. For instance, if we have a child that is wanting to be way bigger than the parent might decide, no, you're actually going to be this size, and maybe clip it in some way. Now, the other thing that I want to talk about is how kind of the different strategies widgets use for sizing themselves. So we've talked about the text widget, right? And a text widget on its own actually takes up some intrinsic width and height. It actually wants to take up a certain amount of space because there is text there that it's trying to render, right? It creates a box the size of the text. That is how big that thing needs to be. But then you have the other widget, another widget like the container widget, right? And if I wrap this in the container, we can see this in action. I kind of talked about this earlier. If I show a background color here, colors.pink, we'll see here that the container isn't trying to be any bigger than the child. In fact, it's trying to shrink to be the size of the child. And that's another sizing strategy that some widgets use, is that they will try and essentially wrap the child widget as tightly as possible whenever it can. And container is one of those. Card is another one of those. And then you have some other widgets that try to be as big as possible. And in code, how you actually do that is by setting their width and height to essentially be infinity. So they will tell the parent, hey, I am trying to be infinity wide, right, or infinity tall. And the parent widget will obviously say, that's impossible because the screen is this big. And so that is how large that widget will then become. So with that being said, let's take a look again at the column widget I was talking about earlier. or that I briefly showed off earlier. And let's add some text items in here. We'll add just a few of them. And things are stacking up, starting in the left-hand corner, going down just as they did before. But now let's wrap the column widget with a container, because remember, containers try and match their child. They try and shrink wrap the child, if you will. So let's say color is colors.green. And so you'll see I have a green bar going all from the very top of the screen all the way down to the bottom. And that's because a column in its vertical axis, which the column calls the main axis, that's its vertical axis, it tries to be infinity high. Now the parent obviously is going to say, the parent in this case being the scaffold here, the parent is really the container, but the container is just going to kind of pass the width and height through. So then the scaffold is like, yeah, you actually can't be infinity high. Here's how tall you can be, and so the column will adjust to be that high. But the horizontal axis, or what the column calls the cross axis, it is actually only the size of its children. And so there we see the kind of that shrink wrapping again to some extent. It tries to match its children's width and height. If I go in here and, or not height, but just width. So if I come in here and add some more text to one of these, we'll see the whole thing grows to match the width of the largest item. Now, the other thing that we're seeing here is that all of these items are actually center aligned inside of here. One thing I totally forgot to show off with the text widget is that you can provide a style object that adjusts some of the styling. So this might make a lot of this easier to read if I add this style. Oops. There, now these are a lot bigger. So every item in the column is being centered across the cross axis. Remember, the cross axis is what the column refers to for its horizontal axis. Now we can actually come in here and change the way that this cross axis aligns itself. So I can come in here and say start. So cross axis alignment start, and that adjusts everything to left align itself. There's also an end, which will right align. And then there's a center, which is what it is by default. And then another one is stretch, which will force each child's width to grow to be as wide as possible. So now, if I come in here and wrap one of these text items with a container so we can see what its true width actually looks like, say colors.pink. We can see here that pink row goes all the way across the top because remember, the parent widget has the final say in what the size of the widget actually is. So even though text is trying to be, as small as the text that it's actually trying to render, the column is forcing it to extend all the way to the edges of the screen. Now, everything I've just talked about, oh, wait, there's one more thing I want to mention before we continue, and that is the main axis alignment. So with main axis alignment, I can align how these items are laid out in the vertical axis. So right now they're set at the default of start. So they're up at the top, but I can also say end. I can also say center. And now they're horizontally or vertically centered. I can also use some spacing options like space around to distribute the space around each item. There's also space evenly so that every item, even in between the edges, has the exact same amount of space. And then there's space between, where the edge items go all the way to the ends, and the rest of the space is distributed in between those. Now, the other thing I want to mention really quick, let me make this guy just a little bit smaller, is that everything I just talked about also applies to another widget called row. And row lays out the widgets horizontally. It does the exact opposite of column. And also the terminology changes just a little bit. So main axis in this instance refers to the horizontal alignment. So I could say main axis alignment center And now you'll see that they all center. I can also do space between to adjust them to all have the same amount of space in between each other. And then I can also do the same thing with the cross-axis alignment, right? So I could say cross-axis alignment dot stretch, and now each of these items stretch to be as tall as they possibly can. I could also try and say something like, center, which is actually the default, but that doesn't really matter here because these are all the exact same height. So if I come down here and add a container, set its width to be 20 and height to be 200, and set its color to be something like black, you can see here now we have an item that's stretching out the row and vertically aligning all of its children. But once again, we can adjust that. So I could say start to put everything up to the start, or bottom, or not, sorry, bottom, end to put everything to the end, and then stretch again. And one thing interesting from here is that, even though we've specified a height for our container, we're seeing the same thing that we saw with text, where the widget itself is still expanded to be as tall as possible, even though we've set an explicit height. And that's because parent is the ultimate deciding factor in how a widget is sized, and can kind of override the widget to some extent. All right, now the next thing I'm going to jump over to, let's go ahead and discard all this. Come on, discard all of the changes. And let's go to our next section, which is the list view. So list view kind of solves one big problem that column has by default. So one thing that we didn't run into with column, because I didn't add enough content, is that a column doesn't scroll. So if I added enough content into that column to hit the bottom of the screen, what we would actually get is a layout error, because even though the parent is trying to, the parent has the ultimate deciding factor in how large a widget is, but if that widget still tries to be bigger than that, it'll essentially just throw a layout error. So let's go to the list view, which is almost exactly like a column, except that it can scroll. So we'll go ahead and add list view. We'll attach some children, just like we did with the column. We'll add in some text widgets here. We'll say test, and then we'll make these really big with size 40 again. There's all sorts of properties we can change in here. We can change the color. We can change the font weight in here. There's a lot of stuff you can adjust about a font or some text through this text style. And then let's repeat this a whole bunch of times. Okay. And now you can see here that we are scrolling. Not too much. Let me add maybe like a few more of these. But yeah, now we have enough content that our list actually scrolls here. And this is fine. One thing I want to talk about really quick is let's actually wrap list view in a container and set its color to be green again, so we can see how large the list view is. You can see here that basically this entire area of screen is the list view, but its width goes all the way to the full width of the screen. So that means that list view essentially behaves as a column whose cross-axis alignment is set to stretch, and its main axis alignment is set to start, right? Because every item starts in the upper left-hand corner. So this is fine. Like, this is a great way to use list view. But one thing that, if you've ever done any native mobile development before, you're probably familiar with how stringent most of those platforms are with scrollable lists. They understand, the people who make these platforms, that when you have a list with hundreds or thousands of items in it, creating all of those items and trying to render them to the screen at once, which is exactly what we're doing here, can be incredibly inefficient, especially because you're only actually seeing a few of those items at any given time. You're not seeing all of them. And so normally, the native mobile platforms have somewhat of a convoluted way of handling this. It's never been at least in my mind, something that's been easy to set up. It requires some extra legwork, right? You have to take your data source and give that to the platform, and then tell the platform which each list item should look like, and then implement another method that takes in some kind of index from your data source, and then build that piece of UI, update that piece of UI to have that bit of data. And it's not too bad, and Flutter has a way to do this as well. In my opinion, it's a little bit easier to understand than some of the others, and definitely a lot less code. But the reason that they do this is so that as you're scrolling, whenever an item leaves from the top of the view, that item gets moved down to the bottom and reused, and its content just gets updated instead of having to create a whole new object to handle all of that. And also so that you don't have to create all of those objects right up front. You can kind of create them as they're needed. So in Flutter, how we can do this is using a different version of the list view on a different constructor called the builder list view. So we'll say Listview.Builder, and instead of passing in children, we'll pass in an item builder. Now, item builder takes a callback function that takes in a context and an index and returns a widget. And in this case, I'm going to use the list tile widget, which is just a really great way to put some item in a list. That list tile widget takes in a title. I'll use text to represent the title, and I'll say item and interpolate index. And then the other property we need to pass to Listview.Builder is our item count. And basically what's going to happen is for every item in the list, this item builder will get called and passed in the current index that it's trying to render. So I can actually just give this a number right here. So if I just give this the number 200, and then let everything refresh, we now have a list with 200 items in it. And if I was actually trying to base this off of data, maybe like an array or something, I would use the array's length right here, and then I would use this index to access that array, pull out any data I need, and use that to render each item in the list. And I could also, list tile has an on tap property, so I could add that here and print out the item that was selected. So I'll say print item number and then at index. And you'll see now another nice thing that list tile does is now there's an actual animation that happens whenever I tap on one of these items. And you can see in my console the current item that I click is being printed out. And there's another version of Listview called Listview Dot Separated. And the only difference between that and Builder is that you can also provide a separator builder that has the same method signature. And in this case, you return some widget that's going to show up in between each item. So in this case, I'll use the divider widget and set its thickness to 5 and color to black. And now you'll see there's a bar in between each item. And Flutter was able to handle this automatically for me. I didn't have to update this item right here to then be like a column and put the divider just below it. And then also check if I'm on the first one to add a separator just before it. Because you can see right up here, like, scroll all the way to the top. Oh, wait, nope, it didn't add one in the beginning. I thought it had. But you might even be able to control that. Let's see, could be wrong here. Maybe not. Okay, maybe you can. Oh well, you could always just prefix the, wrap the list view in some type of column, and then put something just above it if you needed an additional separator there. Anyways, so that is list view. How are we doing on time? I think I'm going to skip over the forms and inputs section for right now. And I'm going to come back to that one at the very end if everything else goes smoothly. So let's skip over to our state management that I was going to talk about. So let me reset my repo. Changes. State management start. Now, one thing that I do need to do here is in this setup, I do need to install an additional package. So this pubspec.yaml file is where you store all of your dependencies for Flutter. and there's this dependency I need to pull in called, it's simply just called provider. So provider is a package created by the Flutter community for doing global state management in an app. There's lots of ways to do state management. You know, there is no one size fits all. In Flutter, I've seen people use the Redux pattern. In fact, if I search, I'm searching this pub.dev website, which contains all of the packages available for Flutter. I'm pretty sure that there's a Redux package. Yeah, so there is a Redux package out there that you can use if you don't want to use provider. There's also another pattern that's pretty popular in Flutter called the block pattern, which stands for business logic components. And it's something I've looked into briefly and understand the basics of. It's not something I'm going to be touching on in this presentation, but essentially it uses Dart streams to manage your state and update, you know, the appropriate people. So you might have all these widgets listening to the same stream, and then, you know, when some new data pops up in the stream, then the UI will automatically update. And that's how they handle reactivity with the block pattern. But provider, this package allows us to create our own you know, classes in our project. I like to call them provider classes. In fact, I usually prefix or add the provider suffix to these classes. And these provider classes hang on to some bit of state. And then these provider classes can also contain methods for updating that bit of state. And whenever some piece of data changes, that provider class will be responsible for notifying anyone who's listening that there's new changes. And with some built-in classes to Flutter, that notifying process is actually incredibly simple. And then the other thing the provider package does is basically allows you to easily pull instances of these provider classes into any widget that needs them. So the first thing I'm going to do is I'm going to run this, I'm going to click this pub get button right here, and that's going to run this command for me, flutter pub get, and that will install the package for me. And then the next thing I'm going to do, there's a few steps to do. So first things first, I'm going to create my provider. And I'm going to talk, I need to decide what type of data I'm trying to provide. And in a few minutes, we're going to look at making some API calls. And I found a API that provides trivia questions. So I'm going to create a provider of trivia questions. So I'm going to call this trivia questions provider. And something I'm not sure if I touched on last time, but Dart packages use an underscore in between. They follow snake case when for file names and for package names. So you never use snake case in code, but whenever you create files in Flutter, or in Dart, the standard is to use snake case instead of like camel case or kebab case or any of those kinds of things. So trivia question provider, and then we'll create our class in here, as I mentioned, trivia question, and then I like to suffix it with provider. So this is just going to be a basic class. And then I also want to create a class to represent an individual trivia question, essentially a model. So I'm going to create a model here just to represent the type trivia question. Now, something I'll say is that, oh, whoops, put this in the wrong folder. Let's create new package. Models, I'll move that into there. Now, one thing I'll mention is that, oh boy, what did you just do? Undo that. That's what I was trying to do. There we go. In some examples, you might see these provider classes actually referred to as models. That's perfectly fine. I tend in my projects to have an actual models folder to represent all the various types in my project. And so for that reason, I like to call these other classes, the ones that are going to actually hold on to the data themselves and not represent the type of data to be providers. So back to trivia question, let me copy in just a little bit of code that is going to represent all of our trivia question data. And we're not going to use all of these things. Most of these properties are in here just to represent the data that comes back from the API. But you can see we have a category type. The main two that we're going to use is this question and correct answer. And then we have a default constructor here that just allows us to pass all these through as named parameters. So it's pretty easy for us to create a new instance of trivia question. So then back in my provider, this is going to be the class that actually stores the data. So I, first off, the main thing this is going to store is a list of providers. So I'm going to create or not providers, questions, sorry. So I'm going to create a new list of trivia questions. And that will automatically import that package in here from that file. And then I also want a method, let me double check the name of this guy, called add new question to update this list. Add new question. And you'll see why I'm actually using a method here instead of just having some widget add to this list directly. Trivia question. New question. And then from here we'll say questions.add new question. Okay. So pretty straightforward so far. Now we get into the parts where we're actually going to work with provider. So the first thing we're going to do is in our main.dart file, which ignore all of this stuff. After we look at state management, we'll look at all this route stuff. But the first thing I want to point out is we're going to wrap our main app in what's called a multi-provider. And this is not how you have to use this package. Multi-provider is just one of the widgets that the provider package, which automatically got imported up here. This guy is the top. A multi-provider is just one of the ways to set up these provider classes. So, and it's really easy for setting up multiple of these providers. So then the multi-provider already takes in a child, which is our material app widget. This is our very root widget. And it's fine that multi-provider is now the root widget. This actually doesn't try to render anything to the screen. It's all just kind of about providing some data. So then we add our providers, which is an array of providers. Now, it's not quite this class. Instead, we're going to use another class, kind of a factory to some extent, to create an instance of this class for us. And that factory class is called, in this case, is going to be a change notifier provider. And this takes a create method, accepts a context, and then from there returns a new instance of our class. So right here, this is where we'll say trivia question provider and create our instance. And so what's going to happen is, whoops, what's going on here? Change. So we're getting a little error here because this type doesn't extend a certain class that this is expecting it to. Not the end of the world. We can go fix that really quick. So one class that we're expected to extend is this change notifier class. And this actually doesn't come from provider at all. It comes from Flutter material itself. And we'll talk about what this class actually adds in a little bit. But in order to use it with this change notifier provider factory, we do need it to extend that change notifier. So here is essentially our factory. So multi-provider, whenever anywhere in one of our widgets we want an instance of this class, it's going to ensure that this method gets called, and then it's going to take the instance of that class, the object that this creates, and it's going to hang on to it. And if any other widget requests an instance of the class, it's going to give it that same instance. So ultimately, this change notifier provider right here and multi-provider are going to create a singleton of this class and provide it wherever it's necessary. So now we can finally get down to our screen, which is our state management screen. And this is set up to look just like any of our other starting screens. I'm also going to come up here and add some code that's already written because this gets a little complicated. Let's see here. And I also realized that I totally skipped over some stuff when talking about column. So this might actually be a decent place to take a step back and write this out. So the first thing I'm going to do is I'm going to add a column here with some children. going to add a raised button. This raised button is going to have a child, with some text. And this will be add dummy data. And so this is going to add some dummy data into our trivia question provider. And then on press, we'll come back and fill this little bit in later. Next in our column, we're going to use a widget that I haven't talked about before called Expanded. And basically, Expanded inherits from another widget called Flexible. It's basically the same thing as a flexible widget. And what Flexible does is this actually is kind of the Flexbox from CSS in Flutter. So what Flexible will do is it'll take all the extra space that's available and fill it up entirely. And it can be provided a child, and it'll make that child fill up all that space entirely as well. And the expanded widget does the same thing, but you don't have to provide it all the same arguments you do. It has some default arguments. With Flexible, you have to provide it a flex value, which is how much of the free space you want it to take up. So if I have two flexibles here, and one of these is 2 and the other one is 1, this guy is going to take up 1/3 of the free space. Well, this one will take up 2/3 of the free space. But expanded is just a simple way to say, like, take up as much of the free space as you can. And then in expanded, we will use a list view. So here will be our list view. And the reason I'm doing it this way is because now we can have a button up at the top right here, and then a list view. If I actually add a text widget here, we'll have our list view that scrolls, but it doesn't scroll the button. It just scrolls the text here. The other thing I forgot to do is this list view is going to be a builder, not the children method. So builder item builder will be context and index. And we'll just simply, for now, just return a list. Okay. And we'll come back to this once we have our data stuff figured out. So now we need our instance of our question provider so that we can actually start filling in some dummy data. So up here at the top of my build method, I'm going to create a new variable in this method called Trevia question provider. And here is kind of where the magic happens. So here I'm going to say provider.of context. And then I need to import provider. Provider is comes from the actual provider package. And then right here, the of method actually accepts a generic type argument, which is the type of provider that we're trying to get out. So in here, I'll say trivia question provider. And just this one line of code right here is going to go up to our multi-provider widget and request an instance of trivia question provider. Now this dot of bit, remember that this dot of and then context, this is actually a pretty standard pattern in Flutter to get some kind of global piece of information. In this case, it's some an instance of our provider class. But we'll see in a minute when I show off some of the how this navigation is happening between screens, what exactly this means. So we'll come back to that. So now we have an instance of our trivia question provider. So I'm going to copy and paste in a method I wrote earlier called add dummy data that takes in our trivia question provider. And let me make sure we import all of our stuff here. And it just creates some new instances of our trivia questions and uses the add new question to add it to our list of questions. And then in here, in our on press, we can say add dummy trivia data and pass our provider through. Now the next thing is to actually use our questions to render out our list tiles. So to do that, I'm going to first come down to item count here and set that equal to trivia question provider.questions.length. And then inside of our method right here, our item builder, I'm going to use that index to grab the current trivia question that we're trying to render. is equal to trivia question provider dot questions at index. And that gives us a single, if I look at the type of this variable right here, what was it? Control J? Oh, it's not popping up. Oh well. The type of this is just simply trivia question. It just pulls that one of them out of the array. And then let me copy another method, because one thing I'm going to set up is so that when you tap on a list tile, it's going to bring up a pop-up that shows the answer to the current question. Because we're just going to list out in the list tile what the actual question is itself. So I have this method here, show pop-up, that takes in a context and a message and simply uses this alert dialog to show a full screen, like modal type pop-up. And then let's copy our list tile from here. So in here we have our title that is just the question, and then on tap we run show pop-up context trivia question dot correct answer. Now if I save all this, we still don't see anything. If I push the button, ooh, we still don't see anything. Well, if I jump back over to trivia question provider, one thing I had mentioned kind of subtly was that whenever we update our data in our provider here, we need to tell anyone that's listening for those data changes that there is new data. And that's actually where this change notifier superclass comes in. This change notifier class gives us a really simple method called notify listeners that we can call that will notify the listeners that there's new changes to the data. And because I ran that, now when we click add here, we see we get 3 new questions. It's the same 3 questions, but we get all those questions added into our list here. And if I tap on one of these, we get the answer in a modal window pop up. So I'll first stop. I know I just covered a lot. If anyone has any questions, feel free to raise them right now. If not, I can keep going. But that's kind of the basics of how to use the provider package, which is just one of the many methods of handling state management in a Flutter app. And it ends up being pretty simple most of the extent, right? Like you create a class, store your data, you make sure to provide it at the very top of your app in this multi-provider, and then you just request an instance of it and use that data as you want. And this, what's happening here is when I call notify listeners, that marks this, wherever I use this provider.of, that build method needs to get rerun. So that's what causes the UI to update with all that new data. So yeah, any questions? Okay, I'm gonna keep going. Now next I'm gonna talk really briefly about navigation in the app. So if I jump back over to main.dart, you'll see I have this variable routes that's a map of string and, oh, this is some type of method. Let's see what it is. A widget builder. So string and widget builder. And I pass all these routes directly into our material app. And if you remember from last month, we actually had this material app in our starter Flutter project. But it had, instead of this initial route and routes, it just had a home property where we passed in the UI we wanted to render. But instead, I'm using this routes and initial route. And what ends up working with how this works is whatever the current route is, it's going to run up here to our routes definition and run this method to get what it should display on the current screen, right? So the initial route is landing. So that means it's going to run this little method right here to create a new instance of our landing screen and render that. So if I jump over to landing screen, you'll see this has a scaffold, an app bar. It also uses the center widget to actually horizontally center the column, and then the column uses the main axis alignment to vertically center everything. And so we have our buttons all centered there. And then we just have a whole bunch of raised buttons on the screen. And now when we want to switch to a different route, that's where things get a little bit more interesting. So if I go back to landing screen, whenever one of my buttons gets pressed, I run this navigator.ofContext.push named. And if you remember right, I said pay attention to that .of syntax because that was going to come back again and again. So what's happening here is this Navigator class, this is a widget that lives somewhere inside of Material App. As Material App renders, it has a whole bunch of widgets it sets up. And one of those is a Navigator widget. A Navigator has a static method called of that takes in a build context and returns an instance of, let's actually go look at it, Navigator state. So if you remember back to the very beginnings of stateful widgets in Flutter, stateful widgets have a corresponding state object. So the Navigator widget that Flutter renders in our Material app, it has a corresponding state object. And this of method on the widget itself, the static of method, can find us an instance of that state. And once we have an instance of that state object, we can call methods on that state object. So right here, push named is some method that lives in the state object that knows how to push a new route onto the stack. And so we use this navigator.of context to get that. And now this build context, every build method gets one of these build context parameters. And basically this context is an object that kind of represents all the widgets that have been built up to this point in the tree. And it's a way for us to reach back up to the tree and pull some data out of some other widget. So in this case, we're going up the tree to the Navigator widget, using the context to then pull the Navigator state out and then run some methods directly against it, right? So in this case, the push named method lives directly on the Navigator state. If I scroll up, this is in Navigator state, somewhere in here. I skipped over it. Anyways, this push name method is on navigator.state, and so that's how Flutter pushes a new route onto the stack. So when I push this button, built-in widgets, this method gets called, pushes in the built-in widgets route. So if I go back to main.dart, built-in widgets corresponds to building a new built-in widget screen, and there we can see we have another set of buttons for some subscreens there. The other thing I'll mention is that this bit of grabbing information from the Navigator is kind of built in, like the Flutter uses it itself. Right up here, we see that whenever I go into a new screen, our app bar automatically has a back button. I did not add that anywhere. In fact, if we go look at built-in widget screen, which is a nested screen here, this app bar looks like any other app bar that we've rendered. So Flutter basically looks at the stack of screens that have been pushed on, and if it's greater than one, it renders a back button in the app bar automatically. And this back button, essentially, whenever it's pressed, it's going to do simply just navigator.of context, and then there's a method called pop to pop the last screen off of the stack. So that's kind of how navigation works. You use this navigator.of, pass in a context, and that will get you an instance of the navigation state or the Navigator state, which then you can call all these methods for manipulating which page is currently shown. Okay. So we talked about state management, navigation. Now let's move on to networking and working with JSON data. So let me reset everything here really quick. So discard all of the changes. And let's go to the network in JSON. Okay, and we'll jump down to networking in JSON. So where I'm actually going to have most of this networking in JSON data screen is actually going to look almost identical to our state management screen. We're gonna present the same basic UI. So I'm actually just going to copy and paste a whole new class here. So this is almost exactly what we were looking at before. The only difference is that the button now says load trivia questions. And instead of loading in some dummy data, I have a method here called fetch trivia questions. And that doesn't yet exist on our trivia question provider. So let's go ahead and add that really quick. So I'll say, instead of a void, this is going to be a future, because this is going to be an async method. So we'll say future, what do they call it again? Fetch trivia questions. Fetch trivia questions. And this will be an async method. And the first thing I'm going to do is I'm going to come up here and I'm going to import the HTTP package, which should be installed. Okay. It's not auto-completing. What's going on here? I'll just copy and paste it in. So this HTTP package, it's already been installed over here in my pub/spec YAML. This is something that's been here for most of the time that we've been working. What's going on there? Spell something. Questions. There we go. So this I'm also importing this under a namespace because this imports a whole bunch of global function, and it's a little bit more readable to have those global functions live under a specific namespace. So the first thing I'm going to do is I'm going to create a variable called response and set that equal to await http.get, and then pass in a URL. And the URL for hitting this trivia data is right here. So this comes back with 20 random trivia questions. And we're awaiting this. So right here, our code is going to pause and go make this network request. And then we come back with a response. The next thing I'm going to do is try and grab the JSON data. So I'm going to say JSON decode, and I'm going to pass in the body, which will just be a string of JSON data. And this JSON decode, this comes from the Dart convert library, which is like a built-in part. It's part of the standard Dart library. And this converts this string into a map of string dynamics. So it contains key value pairs, just like JSON would. And then one thing I know right off the bat that this JSON data has is a results object. And that results is a type of list dynamic. Now one thing I'll point out here is this code is not very safe. If for some reason this came back without this results object, this would most likely fail. If that results object was null or a string or anything besides list of dynamic data, this would also fail. At runtime, Dart's going to do this check to make sure that this is a list of dynamics, and it'll throw if that's not the case. So the next thing we need to do is we have this variable JSON that is a list of dynamic, and we want to convert that into actual instances of trivia questions so that we can add them into our list of trivia questions. So in there, I'm going to say var trivia questions equals json.map, and this is just like the JavaScript map. It's going to loop over each item and convert it into a new item. So we'll take in the trivia question, and then right here, we need to do a little bit to convert each one to a trivia question. One other thing I need to do is that the map method returns an iterable, not a list, and I actually want a list, so I'm going to convert this to a list using toList. So how can we do this? Well, one way is to go back to our trivia question model and add in a factory method. And if you remember what a factory method is from talking about Dart, a factory method is basically a static method on a class that returns new instances of the class. So it's essentially a way to have a different constructor, multiple constructors, and in that, it's a way to have a static method that returns a new instance of the object. So it's like a constructor with a return statement, because normally constructors don't have return statements. So I'll say trivia question dot from JSON. What is it complaining about? And we're going to, in here, take in a map of string dynamic. I'll call this the JSON data. Now, even though this isn't like a JSON string, it's kind of convention in Dart to refer to these maps of string dynamic that represent some data from JSON to just go ahead and call that JSON. And then in here, we can have our return statement where we create a new instance of trivia question using the default constructor. And we can say category would be JSON category, right? We could leave it as that, but we can also make sure that it's the correct type at the same time. And then we can go through and do that for each of these items, these properties in our class. Now, if you're anything like me, that is very boring coding to do, and I hate it. So I found there's a great way to automate this completely. And that uses this package called JSON annotation. And this was not straightforward to figure out, and it's a little convoluted, but once you have the system set up, it definitely, it works great to, for continual usage. So I'm going to add this Json serializable attribute to my class. And one thing I know just from looking at the data is that these two items are snake case in the JSON data. They're not camel case like they are in my class. And so one thing I can do is pass in a field rename argument where I can specify that anything snake case should be converted into camel case during the transformation. Now, this is not enough to actually make this JSON serializable, sadly. Let's comment this out. I have to basically run a build script that's going to analyze this class and all of its properties and basically generate the code that I was just about to write. And so the way Flutter handles these build scripts is by using this package called build runner. And build runner is just a way for any package that needs to do some type of code generation to tie into. And then the Flutter pub command provides a way to run that code. The other thing that I need to do is use a bit of syntax that we haven't covered yet, this part syntax. This is going to be trivia question. So this is the file that the command I'm about to run is going to generate for me. And the part keyword basically says that this class right here, this trivia question class, some of its definition is going to be in another file. We're splitting the class up across multiple files here. So now let's pop open my terminal and I'm going to run flutter pub run build runner build. And this will take just a second. Oh, whoops, flutter pub get. Let's do that first. In switching around things, I needed to refresh all those local dependencies. This takes maybe like 10 to 15 seconds. It's mainly because it's the first time I've had to run it on this project because I've been switching things around so much with my branches and whatnot. Subsequent builds are usually a lot faster than this. And anytime now, Flutter. Okay, so you'll notice my error is gone. And if I come over here and reload this folder, we now have this triviaquestion.g.dart. If I go look at that, it adds some new methods to my class. This trivia question from JSON and trivia question to JSON. And this is exactly the code I was just about to write, but it wrote it for me. And as I make changes to my code, I can rerun that command and I can keep a real simple class in here. I can create many classes and just have all this JSON converting code written for me. And it also, once again, it wrote this to JSON method for me as well that takes in an instance of trivia question and then spits out a new map of string dynamic. So let's jump back here and let's add some nicely named wrappers for those. So I'm going to come down here and I'm going to say, actually, let me just copy and paste these. Maybe a little faster. So I'm going to create my factory method just as I did before. And I'm also going to add that to JSON method, even though I don't really need it. It's just a nice to have. So I take my from JSON, and I'm probably going to have to relaunch this guy. So I'll take my from JSON, pass it through to that generated method, and the same with my to JSON. And so it's going to handle everything for me. And if I come in here and I change one of these properties, I just rerun that command, and these methods will still work the same as before. So now back to trivia question provider. Looking at this bit of code here, I can basically just say trivia question dot from JSON and pass in my map, and it's going to convert that into instances of trivia questions for me. And then the last thing I'm going to do is set questions equal to trivia questions and run my notify listeners again to notify anyone who cares about changes. And now, if I run back over to my networking and JSON screen, I might need to Yeah, I wanted to make sure everything was hot reloaded because I made some changes while I was running a build. So if I run load, we should see we now have 20 questions in here, all loaded from the internet. I can tap on these just as before, and they'll pop up with the answer. Now, most of these questions are either like a true or false or even a multiple choice question. Didn't go through all the effort of actually adding all adding in a UI to handle that. So it's just simply spitting out the correct answer there. Okay, any questions about networking and JSON data before we move on to interacting with the native SDKs? Okay, let me go ahead and reset everything again, and we'll go to, I'm actually going to skip to the end for this guy. I need to remove this file. Whoops. And let's run the Flutter pubget one more time just for good measure. Okay. So for this screen, I have this interacting with native button, and this screen, I'm skipping to the end of everything. Skipping to the end of everything, but it actually isn't working right away, and that's because I think I'm going to need to launch this from Xcode, because in switching branches, I've added some native code to the iOS version of the project, and the simulator doesn't love that. So I'm going to go ahead and launch that from here, and come up here and actually stop this guy. Okay, so we should see that relaunch in a second. But before we do, while that's happening in the background, let's look at what it looks like from the Flutter side. So what I'm doing in here is I'm trying to get the current battery percentage, the amount of battery the device has left. And so we have kind of the standard, scaffold setup. We have a center widget, and then there's this new widget here called the Future Builder, which I'll talk about that in a second. And then we pass it this get battery percent method. And this is the part that I really want to focus on right now. So this is how Flutter can interact directly with native code, which was something that really attracted me and the people I work with at Hero to this framework in the first place, was that we could easily interact with just about any native SDK that we want. So if I go look at this get battery percent method, what I'm doing is I'm creating a new variable called percent, and then I'm awaiting the result of this method channel invoke method. Now, method channel is a static property up here called method channel that's equivalent to this string right here. And basically what I'm doing here is setting up a unique method channel for my app. What I mean by that is you can install these plugins for Flutter or packages for Flutter that they themselves interact with the native SDKs. So there's already actually a package out there for getting the current Bluetooth, or not Bluetooth, but the current battery level of a device. I'm doing it from scratch just to prove a point. There's already plugins out there that do that. And they are essentially doing it the exact same way that I am. And so because of that, it's important to provide some kind of unique identifier to this method channel so that Flutter doesn't confuse your code with maybe a third-party package's code. And so here I'm just kind of using the code name for this specific app. Then down in get battery percent, I run this invoke method on the method channel. It's a lot of uses of the word method, called battery percent. And then I am expecting the return value of this after I await it to be a double. And then I simply just return that double. Now, before going too far, let's talk a little bit about what Future Builder is. Future Builder takes in some future, and then a builder, as the name implies, and then also in the builder method passes in the snapshot that represents where the future is in its current state. And this builder method is going to get recalled whenever the future changes. So when the future maybe errors out, or when it finishes, or when it starts going in progress, this builder method is going to get recalled, and then you can use this snapshot to determine what state the future is in and render some bit of UI differently there. So in this case, if the future is like currently in progress, I'm rendering this circular progress indicator. Now, one thing I'll mention is that this whole get battery percent method runs so fast that you actually don't even see this. But if this was, maybe this future builder was used with our trivia question provider to determine how long things were going to take, maybe while it's loading the data from the internet, it renders this. It's basically just a little circular progress bar. So now if I go to interacting with native, we see a value here. And if this is actually interacting with native code, it is negative 100%. And that is because I'm running this in the simulator where you don't get a real battery value. On a real device where I launched this app, let me relaunch it because I guarantee that's changed. You can see here, maybe it's saying 88%. So on a real iPhone, it gets the correct value, but in a simulator, it gives it negative 100%. So now let's talk about what we do with this invoke method. What happens once we call this invoke method piece? So to start, I'm going to open up Xcode, where I have the Swift code for this project. And this all gets generated. If I actually go back to Flutter here, this iOS folder is what I have open in Xcode. So iOS, the runner project, this is the main project, and I'm in this appdelegate.swift file. And so this whole iOS folder and that appdelegate file all gets generated when you create your brand new Flutter project. And by default, it just has, it doesn't have this bit of code right here, and it doesn't have these two lines right here. It just has this appdelegate, this application method, this call to generated plugin registrant. I don't know how you pronounce that. And then a call to the super application method. But in between there, I have added this bit of code. If we walk through this, the first thing I'm doing is grabbing the root view controller. And the reason I need this root view controller is because the Flutter view controller that the Flutter iOS code sets up to launch your Flutter app in, it contains what's called a binary messenger. And I use this binary messenger to create a Flutter method channel in Swift. And once I have that created, I run this set method call handler method and pass it in reference to this method on the app delegate called onMethodCall. The other thing that I do is I make sure that the name matches the name of what I used back in Flutterland. So if I come up here, my method channel, this matches exactly the name that I use for this guy. So onMethodCall basically gets run whenever this specific method channel that has this matching string calls invoke method. So every time invoke method gets called, Flutter is just going to automatically run onMethodCall. And in there, you get passed in a Flutter method call, which just has details about the call itself. So it's going to have the name that we passed in right here. It's also going to have any arguments we pass it. And then it also gives us this result parameter. And the result is essentially a callback that we will call once our native code is finished doing what it needs to do. So in here, I'm going to check against the method call method to make sure that it matches that battery percent. And if it doesn't, we just tell Flutter, hey, this is not implemented on this platform. And so we're essentially throwing an error here. But if it is battery percent, then we run the native iOS code to actually get the current battery level. And then we pass that current battery level times 100, because it normally gives us just a decimal. We pass that current battery level back to result, which if we jump back into Flutter, which means this await statement will finish and give us back the proper percentage. If we come up here, we're going to use that in snapshot.data to render out the current battery percentage. And then also, if I jump over to the Android side of things, here in Android Studio, let me jump up into presentation mode. Okay, let's open up the sidebar, go into our app here, Java, common example intro app, and look at our main activity. And by default, this class is pretty sparse, but there is a configure Flutter engine method that we can override. This configure Flutter engine is where we, once again, set up our method channel. That Flutter engine we get passed has that binary messenger we need. And then we also pass it our name, which matches what it is in Flutter. And then set method call handler takes in a lambda. And from here, we call a private method. This looks almost exactly as it did in iOS, just written in Kotlin now instead of Swift. We have the same thing, the method call and the result. We make sure that our call method is battery percent, and if it's not, then we say it's not implemented. Otherwise, we call this get battery percentage method and pass that to result in this success method. And that's, once again, going to jump back into Flutter, return that from this future. The future builder will complete, and then we'll see, if we were on a real device, the current device's battery percentage. And so we are now at the end of all the things that I had planned on covering. The one thing I'll mention really quick while we're talking about method channels is there's also an event channel, which can allow the native platform to send events up to Flutter, and as a Dart stream, so that you can listen for changes on the native platform. But this whole system of method channels has made it really easy for lots of people to create various packages for Flutters to port native SDKs over. For instance, one thing that we ran into at Hero is we make pretty heavy usage of a service called PubNub. And PubNub does not make a Flutter SDK for us to use. But they do have a native Android and native iOS SDK, and the community has already come together and made a PubNub package for Flutter that uses this whole method channel and event channel setup for pulling these WebSocket event type stuff and passing them back and forth in between Flutter. So that's all I have so far. I know I skipped over a little bit of stuff there. We're definitely past time, but I wanted to make sure to answer anybody's questions really quick. So does anyone have any questions about Flutter, anything I covered? Any questions about Dart, anything? No? Everyone 100% understands everything that was covered? No, just kidding. Is there anyone that wants me to take a few minutes and go over the forms and input stuff? It's not something I have to go over by any means. Okay, well, I think that is about it. Thanks everyone for coming. I really do appreciate it. I'm gonna post the repository with all this code in the Slack channel. Oh, whoops, is there a chat? There's chat. I'm totally missing chat. Oh, cool. Right on. I'm glad everyone got some stuff out of this. But yeah, I'll be sure to publish this repository and drop it into Slack. And then I also had one more playlist that I was going to share on kind of explaining some more of this stateful widget stuff, as well as a couple other kind of advanced stuff that I didn't get to cover here. But yeah, thanks everyone for coming. Let me go ahead and turn off the recording. But yeah.